What is an interface? How to use it? And what are they good for? Those are the questions I get a lot. They also happen to be my questions when I first learned about interfaces. At first, I really didn't understand why we needed interfaces. Now, after working with them for years, I understand just how indispensable they are. In this video, I'm going to answer all those questions about interfaces by showing off how they can be used in actual code. In case you don't know who I am, my name is Tim Corey, and I learned to be a software developer the hard way, through trial and error. That way leaves gaps. I built this channel because learning C# should be easier. If you want to learn C# the easy way, there are two things I recommend. First, subscribe to this channel. Don't forget to hit that little bell so you get alerts when I publish new videos every Monday. Second, in the description below, you'll see a link to join my mailing list. Follow that link and sign up. You'll get emails about upcoming courses, special discounts, and insider access to all the training resources I provide. Okay, let's start in on learning about interfaces. We're going to start by looking at a project that I have built. Now note that the link in the description to go to the blog post for this video also will have on it the source code at the start of this project and at the end. So you can go to that blog post and download the start to kind of follow along if you want. Now what I have here is a console application that acts as a point of sale system. Now please note that I've really simplified the application in order to keep the focus on interfaces instead of the application actually performing tasks. So instead of emailing somebody, it's just going to say, I simulated sending an email. Okay? So let's look at what it does. We have here a shopping cart. And that is just a list of physical products that the person has put in their cart. Now, again, we're starting in the middle of the process. We're not adding to the cart. We're not removing from the cart. We're just saying that's what it already is, and we're going from here. And so to populate this, I have this add sample data method, which just puts 3 items in the cart: a Nerf football, an I Am Tim Corey t-shirt, and a hard drive. So those are my 3 things that I've put in my shopping cart that I want to buy. Now the next thing we have is a customer. And so it's a customer model, and we'll look at that in a minute, just like the physical product model we'll look at in a minute. But to populate this customer object, I have the getCustomer method, which just creates a new customer model with Tim Corey as the person's name and city, email address, and phone number filled in. So that's it. We have our shopping cart, we have our customer. And then what we do is we loop through, using a for each, we loop through every item in the cart and say prod, which is the product, each individual product, prod dot ship item. And we pass in the customer object. So let's go look at the physical product model to see that prod dot ship item. So here we go in our class library called demo library. We have a physical product model, which each physical product has a title. It has a boolean that says has order been completed, and then it has a method called ship item, which takes in a customer model. So what happens is if the order has not been completed, so equals false, if it's not been completed, then we have that console write line that says simulating shipping this item to this person in this city. And then we mark the order complete. That's it. So the customer model is even simpler. It's just, let's see, like 6 properties: first name, last name, street address, city, email address, and phone number. So that's all the application does. It just loops through the cart and it ships the items. If we run this, I'll pull over here. It says simulating shipping the Nerf football to Tim in Scranton, simulating shipping the I Am Tim Corey t-shirt to Tim in Scranton, and simulating shipping the hard drive to Tim in Scranton. Okay? Really simple application. But this gives us a foundation for looking at how interfaces can help us. So here's the question. Right now we have a list of physical product model. And that physical product is something that actually has to be shipped to the user. But what if we had another product? In fact, let's add a new class. We're going to call this the digital product model. Make it public. And we're going to have the same type of thing. We're going to have a title. Let's just start with a title for now. Okay, so it's got a title, but here's the deal. We don't mail a digital product. Say this is a download of some kind. We wouldn't send that in the mail. So what would we do? Well, we'd probably actually email that to the user. So we have something like ship item. Let's actually grab this whole signature here. I'll copy it. We'd probably have a ship item method, but instead of doing this and doing a console write line saying, hey, we're simulating mailing it, let's actually grab this and we'll say, you know what, we're going to simulate the same thing, but instead of saying that, we're going to say to customer.email address, and then not, of course, in the city. So we're just going to say, hey, we're shipping this item. Let's say saying shipping, let's say emailing. We're emailing this item to this email address. But here's the problem. How do I put the digital product model into this cart? And the answer is I can't. Now, one way to solve this problem would be to create an abstract base class that has title, maybe has order been completed, and a ship item method, and then we could inherit from that and then have the base class be what we have the list of. And that might work, except for if we have things that aren't even or are even less equal. For example, what if we had a service product model where you're buying a service, maybe consulting hours? Well, there is no shipping for that. And so that's definitely not the same thing as a physical product. And if you try and inherit from the same base class, it really doesn't work. So I don't think that inheritance is the right way to go here. But instead what we can do is create an interface. So an interface, let's talk about what that is, and then we'll actually see it in action. An interface is a contract. That's all it is. And so what the contract says is, here's the things that whatever class that implements the contract, here's the things that it will have. Okay? So let's create an interface by hand first, and I'll show you a shortcut for creating it from a class. So right-click on the demo library and say Add New Item, Interface. Now, a naming convention, probably the naming convention for interfaces, is to start them with a capital I, and then have all your words afterwards starting with a capital letter. So, for example, we're going to call this the iProduct model. So both P and M are capitalized. All right, so this is Pascal case with a capital I at the front. And that is quite important because it signifies this is an interface and not an inheritance. And I'll show you why it's important in just a minute. First thing you do, make our interface public. And now this, again, is the contract portion where we're saying these are the things that any class that implements this will have. So let's look at our physical product model. We have a title, has order been complete, and a ship item. I'm actually going to copy all three of these, just the top, not the actual code, and then paste them in here. It's a lot faster to do it that way. Another way of doing it would be to, if we did something like this, like for a property, you could say prop, and then type it out, notice it yells at me. That's okay. The reason why it's yelling at me is because with an interface, you can't have public because everything in the interface is public. And the reason why is this is a contract. And so therefore, you have to have only public things in a contract. Otherwise, there's no point in putting it in the contract if no one can see it. So you have to delete out the public first. And that's why I do the prop and create it and then come back and delete the public. Okay. Now, instead, I just copy and paste it from my class. And so therefore, I can just delete the public off of all of these. But notice a couple of things. First of all, this ship item method has to have a semicolon at the end. And second, the private set doesn't work. Therefore, we have to make it just a getter. So there's our interface called iProductModel. And that's not too hard. Again, it's just the contract. And so that's why we don't have any code in here. There's no code in here. It's just, here's the things that we will have. And these are what's called the signature lines. So this is a method signature. This is a properties signature. And so what a signature is just the important bits. So what it returns, its name, and what it takes in. And actually, the name of the property doesn't matter that much. Now, typically I name the same thing or name them correctly so that it matches up. But that's not a big deal because it's really only the type that really matters. So for properties, it's the get and the set versus just the get. Okay, and again, the return type and the name. Those are the important bits. So this contract right now says whoever implements me will have a title property with a get and a set that's a type string. It will have a has order been completed property with just a get and a Boolean return value. And it will have a method called ship item that takes in a customer model and returns nothing. So that's the contract for iProductModel. So let's go apply this to our physical product model class. After physical product model, we say : iProductModel. And that's it. And the reason why this is it is because we already have the title property, has been order been completed property, and ship item method. And their signatures all match. If we go to a digital product model, notice we don't have the has order been completed. So if I were to implement that interface, iProductModel, it still yells at me and says, hey, you're missing something. Now there's two ways of solving this. One, you could go over to the iProductModel and look at what you don't have. In this case, it's this one right here. And then you can come back over here and either paste it in and put public in front, or you can type the whole thing out all over again. But it's an easier way. If you hit Control Dot when you have the product model selected, or just have the cursor on it, you can implement the interface. And notice it says in this window over here on the right, it has highlighted in green. It's going to add one thing. The public bool has order been completed. So it ignored the fact that we have title and ship item because those are part of the contract. And so it says, I don't need to add those again, but you are missing the has order been completed. Now, the one thing is whenever you add something like that, doing a Control Dot and say implement interface, for every property and every method, it's going to add this throw new not implemented exception if it adds it. And this is a safety feature Microsoft has built in. What I'm saying is we don't want you to accidentally put sample code or blank code into production. but we don't want to break your code in debugging. So if you're just building this application, we don't want to break your code if you're not actually using the has already been completed yet. But if you try and use this before you've addressed this throw new not implemented exception, if you try and access this, it's going to throw a new exception of type not implemented yet. So what you do is just delete those out. And don't forget, I want to add a private set if I needed it, but I will. So there we go. So now I've added something extra. And you may think, well, you just changed a signature. And yeah, kind of I did, but the public version of it was just the get, and that's still the case. It's still read-only from the public side. This is just private and internal. So that's the other thing about interfaces. With an interface, that doesn't lock you into only having what's in the contract. For example, I'm going to actually add another property here. And this is going to be the property for total downloads left. We're going to start off with a value of 5. And the idea here, I'm going to get private set again. The idea with this is that when it comes to digital products, maybe we're going to limit them to a certain number of maximum downloads. A pretty common number is 5. So that's why I've defaulted the total downloads left to be. And what happens is every time we email the item or do a ship item, I'm going to surround this with, so right click, snippet, surround with an if statement. If has order been completed equals false. So that's just saying, let's make sure that the order has not yet been completed. Then what I'm going to do is simulate the email and then say total downloads left minus equals 1. That's to subtract 1 from a total. If total downloads left equals, let's say, less than 1. That way, if we ever had a problem where we skipped 1 or something like that, it's still going to correctly handle that. So if total downloads left is less than 1, so 0, -1, -2, whatever, then has order been complete equals true, and let's just make sure we set that to 0. That way, again, if we somehow skipped 0, went to -1, we're going to set it back to 0, so it's clean. Okay, so now the way digital products work is we check to make sure that the order has not been complete, meaning we haven't finished off all 5 downloads. And as long as we haven't, we email them the information, and then we subtract 1 from the total downloads left. If that goes below 1, then we mark this as having been completed, and therefore you can't download it any more times. So that's a little different from the physical product, where once we check that has been completed as false, once we ship it, we say it's true, because obviously if you order a t-shirt, you shouldn't get 5 of those. You can only get 1 of those unless you pay for all 5. So the logic is different here. And over here in the digital product model, there's even an extra property that is public. And yet that's no problem for the interface, because the interface does not care what properties and methods you have in the class. All it cares is that you at least have everything the contract says you will have. That's all it cares about. And so this contract is for title, has order been completed, and ship item. That's it. Okay? So with that in mind, that kind of drives how we do interfaces. So we just need to have just the things we need to identify as a certain type, like a product model. So we're saying here that products have titles, they have an order completion status, and they have a ship item method. So even if there's more complexity beyond that, it doesn't matter. A product has those three things. Okay, so now we can come back to program.cs, and instead of saying physical product model, we can say I product model. So instead of the actual class, we can give it the implementation, or the interface. And so that interface allows us to put more than one type into this list. Now this add sample data is kind of throwing a fit here. And that's because we're actually returning a list of physical product model, which is instead going to be a I product model. And we'll do the same thing for our actual output. There we go. Now notice I didn't actually change adding physical products. That's still fine. It's just a list of I product model instead. So now we can actually come down here to our add sample data and add a digital product. Output dot add new digital product model. And the title is, I don't know, lesson source code. All right, so there's a lesson source code. That's all we have to do. And now we've added a digital product to our cart as well as 3 physical products. With nothing else changed, and let's actually change, we're going to change the this right here to an I product model. With just that change, going over to interface instead of the actual physical product model class, if we run this, notice we simulate shipping those 3 items, but now we're simulating emailing lesson source code to Tim at IamTimCorey. So that's the first reason why interfaces are so powerful, is that we can depend on those contracts and then work with them accordingly, even if the actual implementation is a bit different for each. So let's look at how that works. For our list, we're saying an I product model, which is an interface. It's just a contract. So what we're saying is, we don't know what's going on in this cart. All we know is everything that goes in this cart will follow after this contract. It will have all the things the contract says it will have. Now, when we loop through each item, again, we look at that as a contract. So we can say, well, I know that, and let's just come down here and say prod dot. Now the equals, get hash code, get type, and toString come with the base object type, so we can ignore those. Those are actually inherited. But these 3 things here, title, ship item, and has order been completed, all come from the contract. So we can deal with, we know about those 3 things, even though we don't know the type of the item. What that does mean, though, is that digital product model has that total downloads left. Well, you don't see total downloads left in this list. And the reason why is because it's not in the contract. Therefore, it's not common across all the items and known to exist. Therefore, we can't see it. It is there, It's just not known. Okay? And we're going to get into how to actually find that. But for now, let's start with just the interface. So, the interface is a contract. Whoever implements that contract will have whatever the contract says they will have, at least. Other items can use that contract as the variable type. And then that variable will be able to directly access anything the contract specifies, but nothing outside that. Okay? So that's the basics of an interface. There is no implementation. There is no source code that you can put in here. It's not like you're going to be able to write code in one spot and then bring it to multiple locations. That's not how it works. But that's actually probably a good thing in a lot of cases, in fact, most cases. Because, for example, with our ship item, the way we ship a physical product is totally different than how we ship a digital product. And that's even a really simplistic example of just doing console write lines. Now, an interface has no modifiers here. There's no public, private, or internal, any of that stuff. It's all public. That's how a contract works. Okay? So you can't put public here. And also, you can't, again, put the curly braces for a method, but instead you put your semicolon at the end of a method. You don't put one at the end of a property because there's already a semicolon at the end of the get. One more thing to note, and that is how this fits into the inheritance model. So if we were going to inherit from physical product model, or let's say physical product model inherits from a base class. Let's just create really quickly a sample base class. Let's call it the physical product base class. A physical product base. Okay? This has nothing in it. It's just to show the inheritance versus interfaces. So if we're going to inherit from physical product base, we cannot do this. That's a problem because the very first thing in line after the semicolon must be what you inherit from. You cannot have it second in line. So therefore, it must be first. And that'll work. With interfaces, you can have them at any point after what you inherit from. So you can mix and match. You can have multiple after this. But with C#, you can only inherit from one parent. Okay? So you can't have multiple inheritances. But you can have as many interfaces as you want, because all an interface is a contract. Now note, if I don't inherit from something, an interface is first in the line, and that's okay. Just know that if you come later and say, well, I actually want to inherit from something, you put it first. That also, let's just point this out too, it's very quick and easy to understand which one is a class you're inheriting from versus which one is an interface. Because interfaces all start with a capital I. Okay, so that's kind of cleaned up there. Now you know how to put an interface onto a class. You know how to implement it. Let's just show off just so you can see it. And I'll actually delete it afterwards. But if you have a class, you know what? I'm not going to delete it. I'm actually going to create it on the customer model. Just so that we have it there. We're not actually going to use it. I just want to show you how to create a interface off of an existing class. So say you have a class and you go, you know what? I actually want to create an interface. No problem. Put your cursor on the class name. Control dot. Extract interface. You get this little dialog here. This just says which things do you want to be included in your interface. They don't all have to be, But in this case, I want them all. And what do you want to name your interface? An iCustomer model is fine. Done. Public interface iCustomer model. There's all of our types. And actually, if you come back to the customer model, it now implements the iCustomer model. So that's just a quick shortcut for creating interfaces. Now, notice I almost said implements, and inherits from, I actually mean implements. And those two different words are actually important. You do not inherit from an interface. Inheritance implies that you're bringing code down with you. That inheritance can only be one parent. You cannot have multiple things you inherit from. But a interface is a contract, and so therefore we said that you implement an interface. And the reason why you implement it is because you actually write all the code. So you write the code for the title, the has already been completed, and the ship item method. So you're just implementing that contract. You're saying, I'm going to do what this contract says I will do. Now let's create one more interface off of just this property here. The total downloads left, because I want to show that off in certain places. So let's actually right click on demo library, say add new item, interface, and we'll call this the digital product. Let's just call it digital product model. Make it public. And we'll paste in that code that I grabbed. And again, we have to take the private set off because we can't have private items. So there's our interface digital product model. I'm actually going to apply this to my digital product. Now I can do this where I say comma and another interface. No problem. Because these are two separate contracts. And I'm saying I will have all this stuff in here in this class. I do. And this one is saying I will have all the stuff in here in this class. And I do. Because all this one has is just this. Now you may be tempted to do that in order to have the items in here and in here. But here's the deal. If you do it this way, if you ever access it as an digital product model, you will only have access to total downloads left. That's it. But what if you wanted to add the ability to see this to our list here of iProduct model? Well, in that case, what you can do is say digital product model is a iProduct model. So what's happening here is we're actually adding all the stuff from this contract into this contract, as well as the new stuff as well. That means that this digital product model can be just digital product model. Now you may think, well, now it's not a product model. But if I run this, it runs no problem. So how is it, let's go back to our program.cs, how is it that this digital product model is going into an iProduct model list when it doesn't directly implement iProduct model? And the reason why is because digital product model implements the iProduct model. So it brings along the iProduct model contract as well. And it says, okay, here's the initial contract. I'm going to add more stuff to it. I'm not going to remove anything. I'm just going to add more stuff to it. So let's demonstrate how we'd use that and why it's useful. So back over here in the program.cs, we loop through each product and say ship item. what if we wanted to say for our digital products how many downloads we have left for that item? Now we could go to our digital product model and put that console write line in here, but let's just say we don't have access to that, or we don't want to modify that. We want it just for the user interface purpose. Well, in our for each, we can say if prod is digital product model digital. Okay, let me show what this is doing. It's saying if this item right here, which is an iProduct model, but remember, that's just the contract it implements. That doesn't mean that's the only thing it does. So if this item is actually also implementing the iDigital product model, if it is, put that into the digital property or the value, local variable. So I've actually created a local variable on the fly right here called digital. And so if it's an iDigital product model, we're going to put that value into here, and I can use that inside these curly braces. It goes away after the close curly brace. So I could say console write line, $. Let's start with for the digital dot title, you have digital dot total downloads left. Okay, so what can I do here? Well, I'm saying I have access to the title, but I also have access to the total downloads left, which is not part of the iProduct model contract. But because I've now asked, are you also an iDigital product model? I've put that into the digital, which means digital has access to everything iDigital product model has, which includes the total downloads left. So now I can access that extra property that only digital products have. If we run this, note that only for the last one, we get this for the lesson source code, you have 4 downloads left. So it only did that for just the one that was actually a digital product. For everything else, it ignored it because this if was false. So it says if this product is an iDigital product model, and it's not. So skip it. Don't assign it to a local variable. This new way of using is actually part of the C# 7.0. So if you're not on, I believe it's Visual Studio 2015 or higher with the latest update, but if you're not on that or higher, that won't work this way. You have to actually do it in 2 steps. So there's the is, and then checking to see if it's null. If it's not null, then doing it. This way is much more efficient, and it's a 1-step process, and it's a whole lot easier to use. So my recommendation to you is if you don't have Visual Studio 2017, the Community Edition is free. You can go watch my 10 free tools video to see how to get Visual Studio for free. I understand if you're in a corporate environment, can't, but if at all possible, get the latest version of Visual Studio at all times. It's just, you get all the cool, fun stuff. So that is right there is really handy because it allows us to kind of cast this into a new type. Now, I don't have to do it to an interface. I could just say digital product model. That would still work. Nothing really changes. But I'm just doing it to a different interface. Now, I do want to point out, remember I said that for the digital product model, if we didn't do this, and instead we have both the, let's just put at the end, iProduct model, like so. Here's the problem. notice it's yelling at me for title because digital now has only access to one property, and that's the total downloads left. That's it. It doesn't have access to anything else because that's all this contract has access to, even though the digital product model implements both contracts. That's why, if possible, and if it makes sense, you have this additive method here where you're saying take everything from iProduct model and also add this one extra thing, or these 5 extra things, whatever the contract says. Doing that, you can still use the interface, and yet you have access to all the stuff you already expected to have. So that's just some of the power of interfaces. The other thing I haven't really touched on, we haven't really talked about here, but you can see, is the fact that my code now doesn't have to change even though I add a new product model. So if I add like I said, a service product model or some other kind of maybe a hybrid product model or a course product model, no problem. My code doesn't have to change at all except for I'm actually adding those sample items to the cart. So if I added, let's right click on the demo library and say add new class. I'm going to call this the course product model. I'm going to get public, and I'm going to implement the iProduct model. I'll hit Control Dot and say implement the interface. And again, I'll take the not implemented exceptions out for my getters and setters. And so here, what I'm going to do is I'm going to say console write line. Oops, let me check the has been completed first. So if has order been completed equals false. Now, some of you may be saying, well, you can do the bang, where you put the exclamation point in front, and then you don't need to do a check like this. And yes, you can do that. And this bang indicates not. So if not has order been completed, also known as false. So if this was true, not true is false. So therefore, false is true. It's a little confusing. Okay. The other thing is this blends in together. So if you're not careful, you don't realize that's an exclamation point and not a character as part of the variable name. That's why I try to be as explicit as possible so that you know, oh, it's false. This really helps new developers because it makes it a lot more scannable for a new developer. So quick rabbit trail. That's also in my top 10 best practices. But yes, so I just make sure that I explicitly say equals false. It does not change anything as far as the actual compiled code. It's the same exact thing. So you're not actually going to have any kind of performance gains or losses by doing this. So if not, it has not yet been completed, then we're going to just say, let's do a $sign first. Added the, let's put the title, course to customer.firstname '*s account. And then we'll close our quotes. And then we'll set the has order been completed equals true. Okay, so really simple, very, very similar to our physical product, except instead of mailing something, we're actually just applying it to their account, but it's a one and done action. So with that all being said, without changing any other part of my, quote unquote real code, which this is simulating a real code, was doing the actual work. Without changing anything there, I can say output add new course product model. The title is .NET Core Start to Finish. And that's it. So without changing any other code, I can hit start. And now we are shipping physical products, we are emailing digital products, and we're adding course products to their account. So that's another benefit of interfaces, is you're not tied specifically to a certain type. That's really big. That's a really important thing. Because if we were tied to that physical product model, which we started with, then we have to change a lot of our code if we want to have other product types. And that causes a messy situation, especially if your application is at all large. And that's why working against interfaces is almost a must when it comes to medium to large applications, especially because if you want to make any kind of change, it takes so much work otherwise. Or you're making modifications to the physical product model, where maybe it's called physical product model, but really is physical or digital. We're kind of trying to shoehorn that in. And that's where you come across companies where you walk in and you say, these names don't make sense. Well, they did originally. It's just that the purpose behind it has changed as the code has evolved. So those kind of things are kind of ugly. So if at all possible, code against an interface, not the implementation. So don't say, customer model, say customer model. It just leaves you open to more flexibility down the road. I recently did a series on design patterns, and I'm not done yet, but I started with the first 5 videos being on a solid framework or solid principles. If you want to see the real power of interfaces, kind of at the next level, watch those 5 videos. Because those 5 videos go over basically every one of them uses interfaces in order to improve and disconnect and make your code just so much better. So that's what interfaces are in a nutshell. That's make sure you go to my blog post and get both the starter source code and also the end, and kind of play around it and see how they work. My encouragement to you is practice this stuff, because the more you practice with interfaces and the more you try things out, the more comfortable you are with them, the more you're going to understand why you need them. Sometimes at first it feels like it's just an extra layer of stuff. But trust me, it's not. It's an essential layer of protection and loose coupling for your application. It really helps you disconnect from those tightly bound monolithic applications. So that's it for interfaces. If you have any questions or any comments, please leave them down below. Thanks for watching. And as always, I am Tim Corey.